I'm just going to correct 6 to 14 for now. So if you have a pen or a marker, go ahead and get that out. All right, so a ball is thrown in the air and has an equation as follows, where h is the ball's height above the ground in feet, and time is t is time in seconds. So whatever is on the right side is my x variable on the right side of the equation. So we've got time and height, every single point, right? It's going to be, sure, we're still going to have x and y coordinates, but it represents time and height. So we're asked to figure out the maximum height that the ball has reached. So first of all, I'm going to enter this into my calculator. I already went ahead and typed this in. Okay. Then I hit zoom standard. Let's see if that does the trick for me. It does a pretty good job. Technically, you could keep it like that. I don't want to see all of this here. So I'm going to reduce my x min and my y min. And usually what I do is I go -2 or -5 for both of the mins. Something that kind of reduces it to just this first quadrant. I also don't need to see too much on here, so I can reduce my x max to probably 5. Okay, and so that's, now you have a better view. It's a bit more zoomed in. Even though the other one, there was nothing wrong with the one that was way zoomed out. I'm just saying it's easier to visualize and to work with it. So the maximum is over at the vertex here. So second trace maximum, you got to go to the left of it and right of it. And so it's, you want to give me the keystrokes. So second trace max, okay, and then you write down the point, the coordinates. So it's 1.02, 7.10. So this is going to be a requirement for you getting the marks, is telling me what you pressed and giving me the coordinates, so I know what you're actually getting it off of this question. And now we say that the max height is 7.10 feet, right? It's that second number that actually gives me the answer. So you have to make sure you state that, or else you don't get the full marks yet. Next, how high is the ball after 2 seconds? So it's basically saying, if time is 2, what is y? Okay, so we're going to go second trace value, right? We use value. We let x equal to 2, and we're going to figure out the y. So second trace value, it's the very first option. X is equal to 2, y is equal to 2.4, and we have feet for the height. So it's 2.4 feet above ground. Okay. At which time or times is the ball 3.5 feet above the ground? Also, how long is it at 3.5 feet? Let's go back to 6 and 7. We're going to go, not bad, just happened. We're going to go 1 and 1 for each one of those. And let's figure out the 3.5. So it's basically saying when the height is, what's x when the height is 3.5 feet? Okay, that's basically what's happening here. So we're going to let y2 equal to 3.5. And then we're going to go second trace intersect. Intersection, right? That's basically what you're finding. So I'm going to grab my calculator. I'm going to go to y equals. Let that be 3.5. Hit graph. It touches it two times within my domain and range, right? So here and here. So I'm going to go find it. Second trace intersect. Let's find the first one here. Enter, enter, enter. I'm going to make a little sketch here showing, right? This is the 3.5 line. And so time 1 here is 0.1630, 4 decimals for that one. You do that again. Am I okay here with my answer so far? I think so. This is 1.877, and it rounds to 8 if you round it to 4 decimals. Okay? So I will give you half a mark for having each one of those present, like you actually finding that. And then I'll give you a full mark for finding how long. How long did it go from here to here? Like how long did it spend above? You got to subtract these two. So I'm going to go delta t is going to be 1.87 minus 0.16. So I'm assuming we're using all 4 decimals. If you do that, I have to double check because I think my key I did not round to 1.71. 1.71 seconds. Is that correct? Or is that off? My answer key is off. Is it 1.88?
Yeah.
No? Yes, no? Are we getting these 2 points or am I off here? I feel like this one I might be off. Let me try this again. 1.8778. Maybe I got the first one wrong. 0.16. Okay, so 1.8778 minus 0.163. Houston, we've got a problem or what? Did I type it in wrong? Vertex is the same as mine. This is the same as mine. .71. Is anybody seeing? Not mistaken. What did you get, Aries? You got 1.88. Chandra? Same, 1.88. So same as this.
Yeah.
Paulina?
1.72, but I only rounded to 2 decimals.
Did you get it, Sarah? Hazen, did you get it? You rounded these to 2 decimals, Paulina?
Yes.
Okay. Today we won't worry about it. So I get 1.71. If you didn't do that, you probably rounded too soon. Today we're not going to worry about it. But moving forward, make sure you do 4 decimals before we get to the very final answer. So there we go. You got 1.88, Eric? Okay, you just stated this one here. Got it. That would be how long, right? How long was it from the very beginning to the second time you reached 3.5, right? That's how long it would take. So, got to be careful there. At which time or times is the ball 1.8 feet above ground? So then I got to let y2 be 1.8, hit graph. And it only really, it starts from time 0 because you start off at a height that is greater than 1.8, right? You start at 0, 2. So the time starts ticking right from the beginning. So it's only one time that happens. So you let y2 equal to 1.8. We're going to go second trace, intersect. And it's second trace, intersect. Don't use the negative time. T is 2.06 seconds. 1 mark for question 9. Question 8 is going to be worth 2 marks. And the breakdown is half a mark for the first time it happens, half a mark for the second time, and a full mark for subtracting. Okay? So half, half, 1. So that's why question 8 is worth 2 marks. What is the starting height of the ball? This is the y-intercept. Second trace, value, x is equal to 0. So when time is equal to 0, y is equal to 2 feet. So you either just looked at the equation and realized that 2 feet is the initial, or use the calculator to do that. Regardless, you get 1 mark for question 10. How long is the ball in the air? In this case, it starts at time 0, it's up in the air until it hits the ground. So it's going to be found here at that x-intercept. So we're going to go y2 is equal to 0, second, trace, intersect. And I find that that is 2.22. Okay, x is equal to 2.22. Just add the word seconds or the unit seconds after it, and you're good to go. That's how long it takes to get to this point right here where it hits the ground. Now, domain and range. We're going to practice that in a little bit. The domain tells me, let me just have another graph here. It starts here, it hits the ground. The domain goes from 0 times 0 all the way till 2.22, right? That's the only allowable x value. So domain would be either 0 to 2.22, or you can go domain, then you need to use the squiggly brackets, I call them. I don't know what else. There's probably an official name for them, but I call them squiggly brackets. Then you got to use the letter T and 2.22 like this. Either option is fine. You just have to stick with one. For the range, this one trips students. They see that this one doesn't start on the ground, so they want to say, oh, it starts here and then goes up to the highest. But remember, if you look down into the future, so to speak, it does hit the ground. So 0 is acceptable all the way to the highest point, which is 7.1 feet, right? That's the highest point it ever gets to. That's given to me by the vertex. So for the range, it's 0, 7.1, or range, squiggly bracket, 0, greater than or equal to. Here you have to use h or h of t. That's fine. 7.1, squiggly brackets. 1 mark for 12, 1 mark for 13. And now we're going to graph this scenario. If you graph it, guys, you don't need to make grids or anything like that. It just needs to have a consistent scale. So add this up already. What did you get so far, right? So basically everything is worth 1 except for question 8. So that gets us to 1, 2, 3, 4, 5, 6, 7, 8. So 8 marks so far, and the graph is going to be worth 2 marks for this one. I'm tempted to do what a lot of students do. They try to cram it into like a small little space there. It would work, okay? Watch this. Please don't do this in general, but if you must, you can make this work. So this will be time in seconds. This is height in feet. Okay, so it has to be there. Let me just zoom into that point. My x-intercept is 2.22. So I'm going to go half, 1, 1.5, 2. Right? And that'll work for 2.22. I'm actually going to put that down already. And then here, I need to go all the way up to 7.1. So I'm going to choose a different scale. 2, 4, 6, 8. There we go. And I label every other point. It starts at 0, 2. I know that, the y-intercept. This is 2.22. And this is 1.02, 7.1. And there you have it. And this is h of t negative 4.9 t squared plus 10t plus 2. So you have to have the equation on there. So I'll say this. If your scale is off, you go -1. Okay? If your scale is off, like it has to be consistent. The spacing has to be consistent. If your labeling is off, take off half. If any of the labels is missing, just take off half. And then the shape today, I'm just going to say it should work out, right? So it's just 2 marks. Just you, the teacher today, you be honest with what you think of your graph. I will be pretty picky on a test or a quiz, so you don't want to be too generous when it comes to this, okay? So that makes this page out of 10. And if you did 1 to 5, way to go. I just, I want to try, yeah. It's out of 9? Including the graph? Then it's 11? Let me double check here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I said 8 earlier? I said 8, and it's supposed to be 9. Yeah, thank you. So 9 and 2 is 11 then. Yeah, thank you. It's out of 11. I stand corrected.